All right, good afternoon. Welcome back to Math and Engineering Help Desk. Today we're going to review for probably your very typical algebra midterm exam that you either are taking or have about to take, and hopefully haven't already taken in the course of this video. But it is what it is, and if not, then maybe it'll help you next year if you take Algebra 1. Anyway, we're going to go over this particular practice midterm exam. This basically covers all things linear equations, linear functions, word problems, graphing, things like that. Typical topics that you would find in an Algebra 1 midterm. So we're going to go through all these items and we'll talk about each one and how to do each one. So in the first set of problems, we're going to solve for x. We're just going to take equations and we're going to solve them for x and get x by itself. And we're going to accomplish that by reversing the order of operations and reversing the operations happening to the variable. So 5x plus 2 equals 27. That means that we're going to subtract 2 from both sides, and we're going to have 5x equals 25, and then we'll divide both sides by 5, and that would give us x equals 5. So kind of reversing the order of operations there. Subtract 2, divide by 5. With this next problem here, kind of the same thing. We have x over 3 minus 5 equals negative 2, so we're going to add 5 first. By adding 5, we're going to have x over 3 equals negative 2 plus 5 is 3. Now here, don't get confused just because you see a fraction. A number divided by 3 equals 3. It means we're going to multiply by 3. So we do that. We multiply 3 on both sides, and that's going to give us x equals 9. Let's put the 3 over here too. Sorry, I'm drawing with a mouse, so I don't mind my handwriting. I'll type when I can. So x would equal 9 in this case, not 90. And there goes my mouse. And then, of course, I already wrote it, but x equals 5 here as well. Okay, so there's that. Now, the next one, this is a situation where we have variables on both sides of the equation. So what I would tell my students is I tell my students to take a look at the coefficient that's greater. It's generally easier to move that to the other side. And I mean greater is in greater absolute value, because here we have negative 4x, here we have positive 2x. So in this case, negative 4x is going to be easier to move over. That would give us pretty much a positive guaranteed on both sides if we move the sign with the highest absolute value over to the other side. So we add 4x here. In this case, we're going to get 6x over here. So that's going to be 6x on this side. And at the same time, since I move my x to this side right, I'm going to move the constant term away from this side and move it over to the other side. So we're going to subtract 20 on both sides. So we're adding 4x to both sides, and we're subtracting 20 from both sides. That's going to give us, that's negative 4 plus minus 20 is negative 24, and that equals 6x. So once we get that, then we just have to divide both sides by 6. And by dividing both sides by 6, we see that x equals negative 4. So that is the solution for that one. X equals negative 4. For this one over here, we have, once again, variables on both sides, but we have to do a little added step here of distributing both sides, and we'll do that first. So we'll have to distribute 3 times x minus 2. That's going to become 3x minus 6 when I multiply each of the terms inside by 3, excuse me. That's going to be 34 minus x. Now what we'll do here is the same thing as before. We're going to collect our x's on one side and collect our y's on the other. So in this case, I've got x and I've got 3x here, so it's better to add the x to both sides in this case with the same signs, kind of same operations. Generally speaking, I like to have positive x values, just it saves me a step at the end. It's nothing wrong with doing it the other way, but it's just how it is for me. So 4x here, and then I'm going to add 6 to both sides here. So add 6 here, add 6 here. That's going to give me x equals 40. X equals 40. 4x equals 40 in this case. So when I now divide by 4 on both sides, that's going to be x equals 10. And we can check these answers too, just to make sure. I'll do the last one first before we check all the answers and make sure they all work. Here we have on letter E here, we have to combine some like terms on both sides first. So 10x plus 2x, that's 12x, and the plus 3 is by itself. And then we have 7 and 5 on the right side. We can combine those to 12, so I'll do 3x plus 12. So here we've got those, and then just like before, variables again are on both sides of the equation. So I'm going to move my x's to one side, my constants to the other. So I'm going to move the 3x this time, since it would give me a positive value here. So that 3x here is going to be on the left, and 3x here on the right. And what I was just to tag on what I was just about to say over here, why I added 4x here, because 4 is less, and it's better to move the term that's lower, not necessarily the lowest absolute or highest absolute value. The term that's lower is easier to move to the other side. That would give you a positive coefficient for x. So anyway, negative 3x on both sides, and we're going to subtract 3 from both sides as well to get the constant term to the other side. And then we have our variables over here, so that's going to give us 9x equals 9, which means when we divide both sides by 9, we see that x equals 1. So let's just check those solutions really quick and make sure that they work. If I plug in 5 here, 5 times 5 is 25, plus 2 is 27, so that's a good answer there. With x equaling 9 here, 9 divided by 3 would be 3, minus 5 would be negative 2, so that's right. With x equaling negative 4 times negative 4 is positive 16 minus 4, so we would get 12 over here with that. On the right side, we have 2 times negative 4, which is negative 8, plus 20, which is also 12. So there we go, true statement there, so that's a good. It's a bad check mark, even for a mouse. X equaling 10 here, we're going to do 3 times 10 minus 2, which is 8 times 3 is 24. And then we have to do 34 minus 10, which is also 24. So once again, we get a true statement. And the last one here with x equaling 1, that means we'd have 10 plus 2 plus 3, which is 15. And then does that equal 7 times 3? Sorry, 7 plus 3 plus 5, that also equals 15. So x equals 1. And notice that when I checked all my answers, I used the original form of the equation just to make sure that I take any possibility of me making any algebra mistakes in the middle to get this answer, to make sure that my answer is accurate. All right, so that's the first 5 equations. We have 2 more to do that are very similar here, so we'll take a look at these real quick. Same deal here. We have some distribution to do and some combining of like terms before we solve anything. That's going to be 3x plus 21 minus 3x equaling negative 3x minus, actually plus 12, because negative 3 times, think of this as negative 4, so it would be like minus negative 12, which is positive 12. Okay, so here we have, now notice here we have 3x and we have a negative 3x. These actually will cancel out because they are opposing terms, on the same side of the equal sign, so they actually would combine to be 0. So we would have 21 equals negative 3x plus 12. 21 equals negative 3x plus 12. So here we're going to take this particular equation, let me just drag this over here, and we'll show the work here. So we're going to subtract 12 first because we're going to undo all the operations that happen to x. So we would do the addition subtraction first. That's going to give us 9 on the left, and that's going to equal negative 3x over here, which means that when we divide negative 3 on both sides, we're going to see that x is going to equal negative 3. Yep, that's right. So then x would equal negative 3. Okay. Now over here we have, this in particular situation here, we have a value for p that we're going to plug in and then solve for x. So here we're going to go x minus 10 divided by 5, and that's going to equal 14. So here x is subtracted by 10 and then divided by 5. So we're going to have a rather large number here, so we multiply by 5 on both sides. That's going to be x minus 10 equals 70, which means if I add 10, that means x is going to equal 80. X is going to equal 80, not 809, 80. Okay. So again, let's check those answers real quick. X equals negative 3. 3 times negative 3 plus 7, that's 4. That's 3 times 4, which is 12, minus 3 times negative 3, which is negative 9. So 12 minus negative 9 is 21. That's 21 on the left here. And then on the right here, we've got negative 3 minus 4. That's negative 7 times negative 3. That's also 21. So that is a good answer. So x equals negative 3 is correct. And then here with x equaling 10, p equals, x equaling 80 and p equals 10, that would be 80 minus 10, which is 70. 70 divided by 5 is indeed 14. So that is also a correct answer. Okay. So that's all number 1. 7 equations to solve, and we do it like that. Number 2, the lengths of the sides of a triangle are x minus 5, x plus 11, and x minus 2. The perimeter is 46. What is x? So you'll recall that the perimeter of a triangle is just the combination of all the sides. So s1 plus s2 plus s3. Don't mind if I just take a shortcut there and not use my subscript on the. I could do it on here, but I'm not going to. And what this means is since all of the side lengths are variable expressions, x minus 5, x plus 11, x minus 2, we're going to just plug those in. So I'm going to use parentheses just to separate those. And then we'll go ahead and combine the like terms. And then, of course, we are also given the perimeter, and that's 46. So if I see here, I've got 1, 2, 3 x's, and I've got negative 5, and plus, since this is plus here and there's no coefficient of the parentheses, I can just combine all of these as is. So negative 5 plus 11, that's going to be 6, minus 2, that's going to be positive 4, so 3x plus 4 equals 46. That means if I add 4 now, let's just make sure that's going to subtract 4, that means 3x is going to equal 42, which means that x is going to equal 14. 14 will be the value of x. And again, we'll just check those answers real quick. 14 minus 5 is 9, plus 25, plus 12. 9 plus 25 is 34, plus 12 is 46. So they do work, and this answer is good. So x equals 14. And of course here I'm just using that to check the answer. I only needed to find x, so, but of course it's always a good idea to check our answers. All right, let's look at number 3. So your number 3 is our first word problem in this test. Your gym charges a membership fee of $35 and $7 for each class you take. Write an equation that expresses the cost C to join the gym and take X classes. So we think of membership fees and things as flat costs, and $7 for each class. And of course, the number of classes you take is different. So we can write 7x plus 35 to be our membership fee. If we took one class, it'd be 7 times 1 plus 35. That equals 42. Now, if we take this and we evaluate and get 8 classes, that means we're going to do 7 times 8 plus 35. That would be 56 plus 35, which is equal to 91. So $91 would be our answer for that. $91 for 8 classes. Let me just move that up so you can see that. There we go. And if I spent $77, how many classes did you take? So this is one where you have to basically evaluate and solve an equation. So 77 equals 7x plus 35 is the equation we would solve here. We would subtract 35 on both sides. That would give us 42 equals 7x, which means that x equals 6. Dividing by 7 on both sides. Okay, so we find that, we're good to go. All right, so now let's go to the next problem here. So here we got, okay, Cheapo Phone Company, what a great name. They charge $15 to join and $4 per long distance call. Wow, that's really $4 per long distance call? Well, Save You Money charges $25 to join and $2 per long distance call. This problem must have been written in like 1980. But anyway, let's go ahead and solve the problem. For what number of long distance calls will the cost be the same? So obviously the variable here is how many long distance calls you would make. So in this kind of situation here, you would have to write an equation. So the equation that's best here is a flat fee plus $4 per long distance call. So 4x plus 15. We'll let x be the long distance calls. And then on the other side, 2x plus 25. So we're just basically looking how many long distance calls would you have to make so that you would pay exactly the same for either of these two old phone companies that probably no longer exist, especially if they're charging by the long distance call. But anyway, let's go ahead and solve this. We're going to subtract 2x from over here to move it to the other side. So 2x there and 2x there. So that's going to give us, and of course we're going to, so we're subtracting 2x over there, we're going to subtract 15 on both sides as well. This is going to make for a very easy counterintuitive solution here. This is going to give us 2x equals 10, which means x equals 5. So 5 calls would give you the same cost. And just to check, make sure 5, of course, what's the cost when both costs are the same? Of course, I'm answering question B at the same time while I check it. 5 times 2 equals 10 plus 25 is 35. And then 5 times 4 is 20 plus 15 is 35. So the answer to B, what's the cost when both costs are the same? It's $35. So that's that. Next. State the number of solutions for each equation. So here, this is kind of a couple ways to do this. We ultimately want to figure out if we have an identity or a contradiction, and then go from there. So in this particular problem here, I would distribute and get these parentheses kind of isolated. So we have 12x minus 18 on the left side, and on the right side we would have 12x minus 18. So when I distribute these two coefficients to these two binomials, I get 12x minus 18 equals 12x minus 18. This is called an identity. That means since it's an identity, when we have the same thing on both sides, then we consider this to have infinite solutions. All right, so that is our first problem there. And then with this one here, 8x minus 16 equals 8x plus 24. You'll notice that when I subtract off, I notice that 8x is on one side and 8x is on the other side as well. So I can actually cancel these terms. When I see the exact same term on both sides of an equation, I can just cross them right off. That means that I would have negative 16 equals negative 24, which is clearly not true. So therefore, this has no solution. This is a contradiction. This is something that's not true. So when we have a contradictions, we have no solutions. With C, I can tell right away that because x is only on the left side and y, there's no x on the right side, this is clearly going to have one solution. Okay, so one solution. And that solution, by the way, is going to be 7. If you want to see the work for it, if you want to try it yourself, you can see that you'll get 7 for that. Okay, next problem. Number 6, the equation P equals R plus WG represents air pressure as a function of airspeed, water pressure, and the acceleration of gravity. Yay, physics. If you have R equaling 3, W equaling 5, and G equaling 2, what does P equal? That's not bad. 3 plus 5 times 2 is what this would work out to be here. If I plug in everything, P equals 3 plus 5 times 2. That would equal 13. Nice and easy. If we're looking for R and we have P equaling 12, 4, and G equaling 2, a couple ways we can go about this. Number one, I can solve the original one for R by subtracting WG. That means P minus WG would equal R. So if I just plug into the left side here, it'd be 12 minus 4 times 2, 4 times 2, which is 12 minus 8, which is going to be 4. So 4 would equal R. Just to make sure, if I did 4 plus 2 times 4, that would be 4 times plus 8, which equals 12, so that works. Write an equation that expresses G in terms of W, R, and P. Okay, that one's a little harder. If we start with the starting form, P equals, P, my bracket, R plus WG. If I've got to get G by itself, I got to recognize that G is multiplied by W and then added by R. That would give you P. So that means that the solution would be P minus R. And then I'm going to put that in parentheses because it's a group, and I'm going to be dividing that group by W to get G. Okay. Another way to look at this also here is if I were to write it out, I would have to subtract R first. That would be P minus R. Oops, sorry. I don't know what happened there. That was weird. That was weird. Okay, let's try that again. Sorry about that. That would be P minus R. I'm just going to write that out because I know that my students have some difficulty with literal equations, so I want to kind of show you what's going on here. So if you subtract R from both sides, P minus R would equal WG, and then you'd have to divide by W because you're trying to isolate the G. So that means that P minus R, excuse me, all over W is how you would express that. Okay, and that would equal G. Of course, you can put the G on the left side as well, but it is what it is. All right, next. Express each situation as an inequality. Inequalities are also part of this exam. So you must be at least 18 to vote. A equaling age, that means A must be greater than or equal to 18. Sorry, that's a funny looking A, I know. A must be greater than or equal to. It's greater than because at least, greater than or equal to, excuse me, because at least means 18 is included. You have to be 18. If it was greater than only, it would say you must be older than 18 or more than 18, you know, something like that. B, you can spend at most $35 on a new shirt with M equaling the money spent. That means you're going to have M is less than or equal to 35. All right. And then the cost to rent a car is $25 plus $5 a mile. How many miles can you drive if you can spend at most $500? So once again, this is a less than or equal to situation. So I'm going to type this one out because it's an equation. 25 plus $5 a mile is 5M plus 25, M equaling miles, and that's going to be less than or equal to $500. That's how I had used when I was a programmer a long time ago. That's how I had to write less than or equal to into the programming languages that I used. Anyway, we would subtract 25 here. We'd have 5M less than or equal to 475. Then we would divide by 5. Since we're dividing by a positive number, we do not need to flip the inequality or anything like that. That would give us M is less than or equal to 95. So 95 miles, and just to make sure, 95 times 5 is 475, then plus 25 is 500. So that works. M is less than or equal to 95 miles. All right, so keeping with inequalities now, let's graph some inequalities. An inequality that represents by the graph below. Okay, this is a good one. Basically here, this is a compound inequality. This is an inequality that is represented by two different situations. So here we would say that x is less than 5 or x is greater than 7. Now, when we see how we have compound inequality here, your algebra class may or may not have gotten to compound inequalities, but if you have two inequalities on the same number line and they're not pointing to each other, we use an or to represent that. So basically, think of this as all of the solutions for this inequality are numbers that are not between 5 and 7. So, that is another way to look at it as well. So x is less than 5 or x is greater than 7. Now, we're going to solve this inequality and we're going to graph the solution. So 4x plus 2 is greater than or equal to 14. So that means we're going to subtract 2. Just like an equation. When you solve an inequality, it's just like an equation. So we subtract 2. That's going to be negative 4x. And that's going to be greater than or equal to greater than or equal to 12. And then I'm going to divide by -4. Now, when I divide by -4, this is one of those instances where we're going to have to flip the inequality. Anytime you multiply or divide by a negative number, you have to change the direction of the inequality. So 12 divided by -4 is going to be -3. And I'll prove it to you by showing you a solution or a number that's not a solution. So here, since it's less than or equal to -3, we're going to put a dot on -3, and it's going to be a closed dot because it is less than or equal to. And then I'm going to draw, at least if I have my ray tool. Do I have my ray tool? I think so. I'm going to draw a ray pointing. Is that the right one? No, I want the other one. I want the one that's pointing away. This one. That one? Nope, not that one. This one. Sorry, I want this ray. I know, I'm a perfectionist sometimes. There we go. That's all right. There we go. Okay, so we want a ray that points to the left in this case. Now, test this out. Test our graph. Make sure our graph works. We're going to make sure that we have a solution on the graph and a solution not on there. So I'm going to say plug in 0. Now 0 should not be a solution based on my graph. So -4 times 0 is 0, plus 2 is greater than or equal to 14. So 2 is not greater than or equal to 14, so that's why 0 is not a solution. If I pick a point that's on my graph, like -5, -4 times -5 is positive 20. Positive 20 plus 2 is positive 22. So 22 is greater than or equal to 14. So -5 is a solution. So it's important to check your solutions to inequalities just by plugging them in and seeing if you get a true statement. All right, next. Now, what's the solution of 14x minus 6 greater or equal to 22? So here they want you to just say, what is a number that would work? So, you can pick a nice and easy number here. You could pick 10. 10 looks like it would work because 14 times 10 is 140. Minus 6 equals 22. So that is a possible solution to that. Of course, they want to know when they say, what is the solution? And of course, I just realized I read this quickly. What is a solution would be like x equaling 10, but the solution, as in we want the whole thing, we want all the values of x that work here. We just got to solve this inequality. So add 6. Still on my thick pen, hang on. That's going to be 28. Change that. 14x would equal 28. Greater than or equal to 28, I should say. Greater than or equal to 28. Now I can't draw. Come on. There we go. That's it, 28. Sorry for that. And then, of course, we divide by 14. Now, because we're dividing by a positive number, we do not change the direction. We keep it at that. X would be greater than or equal to 2. And again, just to make sure, if I plugged in 0, 14 times 0 is 0, minus 6 is negative 6. Negative 6 is not greater than 22, so that is not a solution. If I plug in 2, 14 times 2 is 28, minus 6 is 22. 22 is greater than or equal to 22, so 2 is a solution. All right, nice and easy. Now, into some slope stuff. What's the slope? So in this case, we want to find the slope. We can use some vectors to do it. So if in this case, I'm going to go up 3, and then I'm going to go over 2, right? So when we find slope, the quickest way to do that is just to do that up 3 and over 2. So the slope here is 3 over 2. M equals 3 over 2. So that's nice and easy. Okay. The slope of a line that passes through 5, -4, and 8, 11. So here we use the slope formula. So the slope formula is the y-coordinate difference divided by the x-coordinate difference. So here 11 minus -4 over 8 minus 5. Now it's important that when you do the slope that you are consistent with which point you put first. It doesn't matter really which one you make y2 or the second point or the first point, as long as you use the same for both. So since I used 11 here, 11 minus -4, and then I got to make sure I put the 8 first as well. So this is going to be 15 over 3, which is going to be 5. So the slope of this line is 5. Okay, m equals 5. All right, now, what's the slope of a line with the equation 5x plus 25y equals 3? There's two ways to do this. Number one, we can use the fact that the slope of a standard form line is negative a over b. M equals negative a over b, which means in this case it would be negative 5 over 25, which is equal to negative 1/5. So that's one way to do it. Another way to do it is to just solve this for y and use the coefficient of x. But understand, and I'm not going to do that out right now, but we could. Oops, we could. All right, so understand, of course, yeah, I could do solve this for y and I would just have to subtract 5x and then divide by 25. But note that I would get negative 5 over 25 for my slope. I would get the same thing, negative 1 over 5. So when you have a standard form of an equation, there's a shortcut for you. Negative a over b is the slope. All right, what type of line has zero slope? Increasing, decreasing, vertical, or horizontal? Zero slope is a horizontal line. So we want to use that as our answer for there. Okay? Oh, good. Look at that. Thank you, Pevanos. In the middle of recording, he says, thank you, very helpful. Glad to hear that. All right, now number 15. Identify each increasing, decreasing, vertical, or horizontal. Okay, so now here we have to kind of identify what kind of line we're going to get out of this. With x equaling 2, that's for a vertical line. Vertical lines have undefined slope when we think about them as y equals. The way we write equations for vertical lines is we just do x equals the number that it goes through on the x-axis. For b here, y equaling negative 2x plus 7, the slope here, and here's another subscriber. Thank you, Silver Fox, for subscribing to our channel. Negative 2x plus 7, that's going to be, let's see, y equals negative 2x plus 7. That's going to be a slope of negative 2, which means we have a decreasing function, decreasing slope going down from left to right. A line that's parallel to y equals 5x minus 7. A line that's parallel will have the exact same slope, so that would have a slope of 5. That is an increasing function. And then for a perpendicular line to x equaling negative 4, well, a line that's perpendicular to x equaling negative 4 would be a line like y equals 6. Because that's a vertical line, so a horizontal line would be perpendicular to that. So horizontal for that. Okay, moving forward, we're making progress here. If we have an equation y equals 5x minus 2 and we want the slope and the y-intercept, oh, that's super easy. This would be the one you should always get right on a test. It's always on every algebra midterm, where you have a slope-intercept form of a line. You just have to identify the slope and the intercept. Well, guess what? The slope is 5. So here, that's your m, and then negative 2 is your b. Just don't forget to bring that operation with you here. So in this case, we would say our slope is 5, our m equaling 5, and our b equals negative 2. Okay. Equation for the line. Now, this one's a little tougher. This one's a little tougher. It's going to take, it doesn't really specify what form of the equation you want, but it's always easiest to use slope-intercept form for these kinds of problems. When you have a graph of a function and you just need to write the equation for that graph, super easy to just do the slope-intercept form. So here we go. Slope is going to be, so for number 17, the slope here, we're going down 2 and over 5. So the fact that we went down 2 and over 5 means the slope is equaling to negative 2 over 5. And that would be 2 over 5x, and the y-intercept is on the graph for us. It's 4, so we'd say negative 2 over 5x plus 4. So that's that one. For b, here the y-intercept is not as apparent. Neither is the slope for that matter, but to me it looks like the y-intercept is 3.5. So we're going to kind of go with that. And I'm going to pick 2 points on this line just to do the slope. So I'm going to pick this point here. Let me use my thicker pen in a different color because we're using a red line already. So I'll put a point right there, and I'll put a point right here for the slope of that line. So that's going to be up 3 and 1, 2, 3 over 4. So that's going to be up 3 over 4. That's 3/4 for our slope. So y equals 3/4 x. I like to put fractions in parentheses when I do these. And then we said this y-intercept was like 3.5, so we'll do 7 over 2, or we can also do 3.5. I'll just be consistent and choose to use fractions there. All right, now here, this one's super easy. It's a horizontal line. So when we do a horizontal line, we just need to know where it goes through the y-axis. So since it goes through the y-axis at 5, the equation for the line is y equals 5. So done deal on that. Now, graph the equations. So a couple of strategies for graphing the equations. These equations happen to already be in point-slope form. Sorry, not point-slope form, my fault. Slope-intercept form, so graphing these lines should be a piece of cake. Minus 7, we always do the y-intercept. So in this case, negative 7 is going to be our first point. And then as far as where it should go, we want it to go up 5 and over 1. So if it's at negative 7, we're going to go up to negative 2 and go over 1. So our line should graph pretty much like that. Let me just extend this graph a little bit further. So it's going to look something like that. Okay. And sorry, I'm not using my arrowheads right now, and I'll change that right now. Okay, with the blue line on the next one here. Okay, the next one's going to look good. We'll use light blue for this one. So same deal here. Y-intercept is 2, and the slope is 3/5. So that means we're going to start at 2. So we're going to go to that 2 here, and then we're going to go up 3 and over 5. So since we're at here, another little shortcut here for you is if you go here, 3/5, 3 up 3 over 5. If it was the origin, you can just go to 3/5, but here it's not. You just have to add 2 to the y coordinate, and you can go to 3/7. And so if I make this go to, sorry, 5/5, excuse me, my fault. I'm adding the wrong value there. 5/5. So if I go there, go through that point, that's up 3 and over 5. And again, let's extend this point so we cross through the entire graph. And also make sure that when you graph these equations, make sure you go through the entire graph that's given to you on the test. All right, so that equation is graphed. Now we go to the next one. All right, now we have a standard form, and we're asked to give a x-intercept and a y-intercept. So standard form is nice and easy because we just know that if we plugged in the other value as 0 and solve, that would give us our x-intercept. So for an x-intercept, we make y equaling 0. So that would be 4x equals 12, and that means that x would equal 3. So the x-intercept is 3, 0. For the y-intercept, we do the same thing, except we just cover up the x. Now we have negative 3y equals 12, which means y equals negative 4. So the y-intercept is 0, negative 4. The equation in slope-intercept form. Okay, so the slope of the line, as remember for standard form, m equals negative a over b. So that means the slope of this line is going to be, and this is the coefficients that we're looking at here, that's going to be negative 4 over negative 3, which means the slope is positive 4 over 3, which means that the slope-intercept form of this line is going to be y equals 4/3 x, and the y-intercept is negative 4, so minus 4 would be our answer to that one. Okay. Alternatively, if you want to write it in slope-intercept form, you also could subtract 4x from both sides and divide by negative 3 on both sides. You actually would get exactly the same thing as this. Okay, the point-slope form of a line passing through these points with a slope of 2. Okay, so we're on point-slope form now. Remember, point-slope form is y minus y1 equals m times x minus x1. I actually just made a video not too long ago about it that you can certainly check out for more information about point-slope form. Y minus, so in this case, the slope is, the line, is 7, negative 3. So here we're going to go y plus 3 because we use the opposite. Y minus y1, y minus negative 3 is going to be y plus 3. And the slope is 2, given to us as 2, and then x minus 7 would be our final value for that. And that would be the point slope form of a line that passes through 7, negative 3 with a slope of 2. All right. Next, we're almost there. We got to go to number 24. So we're on number 21. We're almost good to go. What's the equation of a line passing through 8, 9, and 10, 15? Write your answer in slope-intercept form. Okay. So for this kind of problem, super easy if you use the point-slope form and solve it for y. So here what we need to know first is the slope. We know that the slope is going to be the difference in the y-coordinates over the difference in the x-coordinates. So it's going to be 15 minus 9. Sorry, my mouse, I'm on the thick pen, of course. Let me just try to switch over there. 15 minus 9 divided by 10 minus 8. So that's going to be 6 over 2, which is 3. So that's going to be 3. So our slope is going to be 3. Once we know the slope, we can use the point-slope form and simplify that. And I'll use 8, 9 as my point. And I really could use 10, 15 as well, but I'll use 8, 9. Y minus 9 equals 3 times x minus 8. Okay, so what happens here is we're going to have y minus 9 equals 3x minus 24, because I distribute the right side, 3 times x minus 8. And then that's going to be, if I add 9 to both sides, that's going to be y equals 3x minus 15. Just make sure, adding 9 to that is going to give me negative 15. Yep, okay. So that's going to take care of that one. So slope-intercept form, y equals 3x minus 15 would be the correct answer for this. Now, the graph of y equals mx plus b contains points in quadrants 2, 3, and 4, but no points in quadrant 2. Write the appropriate inequality sign. Okay, so this is important. I'm going to just draw on this to give you an example of a line that they're talking about. If it crosses through 2, 3, and 4, sorry, I just realized there's quite a bit of typo in here. 2, 3, 4, but not in quadrant 2. Okay, so there's a big typo in this one. This one here should be quadrant 1, not quadrant 2. So I'll have to fix that before I give this to my kids tomorrow. Quadrant 1. So 2, 3, and 4, but no points in quadrant 1. Write the appropriate inequality symbol. Okay, so here's an example of a line that would fit that bill. If we draw a line kind of like that. That's an equation that fits the bill here, where we have intersection with 3 out of 4 quadrants, but not the second one. In order for this quadrant to not have a line go through it, we just have to consider that the slope of this must be negative in order for it to hit these 3 quadrants. There's no way to do a positive line here and have it not intersect quadrant 1. It just can't happen. All right, so in this case, the slope here must be less than 0. And also, the y-intercept, in order for it to stay away from quadrant 1, the y-intercept also must be negative. So the negative 0 here as well. Actually, it could be it could be less than or equal to, because it could cross to the origin. The origin does not count as to which quadrant, as to a quadrant, I should say. So this could, if I can drag the line, I don't know if I can. No, don't know if it's going to let me select the line. All right, that's okay. It's not going to let me put the line in there. So be it. That's okay. Understand that if this line did hit the origin, it would go through 2 and 4. Actually, no, it wouldn't be the origin. Now that I think about it, no, I was right the first time, because if it was, then it wouldn't hit quadrant 3 in that regard. So it has to be less than 0. Must be less than 0. So I was right the first time. Okay, so if you said less than first and then stuck with it, even though my 30-second explanation of why it's actually less than, then good for you. All right. Now, in this kind of problem, we have to follow multiple directions here. So we're going to go ahead and plot some points and kind of go from there. So plot point 6, 6, and 9, 18. So 6, 6 is right here, and 9, 18, whoa, is all the way up here. Okay, so plot those and then draw a line segment between them. Okay, that's fine. We can do that. Line segment between these 2 points. Okay, done. Good to go. Now plot a point C at 13, 15. So 13, 15, 13, 15 is right here. And it wants us to draw a line that's parallel to segment AB but through point C. So here's point C. All right, so it's interesting. Okay, well, in order to do that, we'd have to know the slope of the line. So really quickly, we can kind of look at this graph and kind of see what the difference of this would be. 18 and 6 is 12, 6 and 9 is 3. So it's going to be 12 over 3. So up 12 and over 3. So if I go from here and I go down 12, that's going to put me at 3. And then if I go back 3, 1, 2, 3, I'm going to put a line starting right there and connect it to that point. And that should give me something that's parallel. Did I do that right? I'm looking. Nope, I went 3. I'm sorry, I was supposed to go 2, not 3. See, I can tell right away. Just I looked at it, I said that's not right. I can't quite look at that and see that's parallel. I'm supposed to go down 12 and over 2. So that would be here. Let me make sure I got that right. 13 and 11, 6 and 9. No, I was right. It was 3. I just got to go to this one here. 6 and 18, 15 and 3. So it should be that. Okay. I look at it from the side. I think that looks better now. I don't know. For some reason, when I looked at it before, it kind of looked like it was going to extend and intersect. But it is what it is. Okay. So, but notice that what I did to do this was here, I used the exact same slope and change from this line to get to this line here. So drawing a line, of course, drawing a line through that means I got to use a line to do it. So pardon my non-exactness on this one here. Let's try to fix that. Make that. There we go. There's a line. All right. Good to go. Now, what's the slope of the line from part B? Well, the slope of the line would be the same as the slope from the line from part A. So since it's supposed to be parallel, so that's going to be, I guess, as I said, 12 over 3. So that's going to be 4. 4 is going to be the slope. Sorry for the huge writing there. 4 will be the slope for that one. Plot a point at 19.7. 19.7, point D. Okay, so we'll grab our thick pen here. 19.7. That's going to be all the way over here. 19.7. And we draw, ooh, this is a tough one here. Okay, so you draw a line there. We want that line to be perpendicular to segment AB through point D. Okay, so actually, no, that's not that bad. Because the slope of the line, since we have the slope already as 4, a line that's perpendicular to that would have a slope of negative 1 over 4, right? So negative 1 over 4 would be the slope of that, because again, negative reciprocals. So here I would draw a line through this point right here. And then if I draw that line through that, that would give me... I'll start at this point right here and extend it from there. That would give me that right there. Yeah, so that works. There we go. That works. Okay, so, and then slope of that line, which we already answered here, is negative 1/4. Okay, so that question is done. Now, last question here. This one here deals with best fit lines. This one's not too bad. The line of best fit is given to you already. You just have to basically interpret a graph for most of the questions. So age is on the x-axis and weight is on the y-axis. The above scatter plot shows the results of a recent survey of weight versus age along with the line of best fit. According to that line of best fit, what is a 20-year-old projected to weigh? A 20-year-old, according to this line, since 20 here, the weight here, okay, according to this would be 20, but again, kind of what's the axis values here? I would imagine in order for this to work, it would have to be something like 10 pounds or something. 20, I mean, because 20 even kilograms doesn't make sense here. 20 kilograms is not that heavy for a 20-year-old. So this is one of those instances where when we do a graph, this graph context really doesn't make too much sense. This weight here should be a much different number. I would say if we wanted to, make it realistic, that we should have something like, 100 pounds, 150, 200, and have it be spread out a little bit more. But again, let's just go with what the problem says and just take it for what it's worth. According to this, if you're 20 years old, you would weigh 20 whatevers. Again, it's weight, right? Weight of what? Who knows? Anyway, I digress. Difference between actual and projected weight for an 8-year-old. So here is an 8-year-old. 8 would be right here. And based on this is going to be something like 12. So actual and projected. So 12 is based on what it actually is. So we'd say 12 for actual. And then the projected weight, we go to the line of best fit, and that's going to be at, it looks like about 7.5. So the difference here between these 12 and 7.5 is just going to be 4.5. Okay, so 4.5 would be that. Assuming the y-intercept of the line's best fit is 0, what does the y-intercept mean in the context situation? That just basically means that if you're 0 years old, you don't weigh anything. 0 years old, no weight, basically is one way to kind of explain that. And the slope of the line best fit, what does the slope mean in the context of the situation? Okay, so this one's a little tougher. I'll pick 2 points that are easy to interpret. I'll say these 2 points right here are not too bad, because 20 over 20 and 10 over 10, so that means the slope is 1. So with a slope of 1, that means m equals 1. The slope, the context here would be that for every year, weight goes up by 1. And again, pardon the context, this is not a problem that I would have written, but it is what it is. You know, it's just have to go with it. Go with what it said. All right. So anyway, hopefully this will help you kind of prepare for the kinds of things you're going to be asked for on your midterm. If you have questions, you're free to write them in on the comments here, and let me know if you have. I'll try to help you out with that, and hopefully you're using this. Hopefully you get a good grade for your midterm, and hopefully you do well with the rest of Algebra 1. Anyway, have a wonderful rest of your day. Don't forget to be awesome.